Hello everyone, welcome to another stream. How are we all doing? Okay. So today, as you can tell by the title, we're going to do some optimization. And we're going to we're going to make this game UI renderer thing super optimized, hopefully. So currently the renderer runs about 0.5 ms, doing about 13 draw calls, which is like, not very impressive, but it's got an impressive feature set. We've got all these sign distance filled stuff and super flexible, right? So the first thing I want to check is if we can make the shader any better than it is already. Just have a quick browse over that. And then we'll get into the tile-based renderer and how we're going to achieve that today. So if we hop into the shader quickly. So the thing is, we removed so this little thing here does a continue, and we used to have one of these for the clip shape as well. So this is like saying per draw command. So every pixel is going over all the draw commands, and what it does is it says if the pixel is outside of the bounds of the draw command, then skip it. Now we won't need this when we do the tile-based renderer, because this loop, or this many iterations is going to be shortened to how many draws fall into a certain tile. So it will kind of be pointless doing this check. But also another thing is as well is by continuing. Remove the wave active man. Right. By continuing, you do create divergence in the waves. Is that true? Well, it was true here earlier. Well, so in a SIMD32, it does a different pixel for each thread, basically, right? So when we land on a continue, some of them will be in, some of them will be out. So that means when it goes down here, you have some inactive lanes, which is fine. But it won't be fine when we do our texture sample, because you'll get some glitches if you do have bitmaps. But we don't use bitmaps, actually. Not a problem. Why did it cause divergence before? Because I had a continue up here, and I forgot why. But anyway, I'm thinking about removing this, basically, and seeing if it reduces our VGPRs. So build. Here's the document that's going to get updated. So right, it says 52. It's actually on 42 VGPRs. We'll rerun it again. Mesa. Right, so this dumps out to this file. Right, it's 42. So the problem is when I remove this, it's going to be slower. Because yeah, it's just going to be slower. Because most of the time, all of the pixels are outside the bounds of a draw command. Most of the time. So it's definitely going to get slower. So that went, yeah, that up to about 4.3 ms. So that increased by about nine times. But the question is, yes, right, we've got less VGPRs. That's what we wanted. So this is better because then the GPU. See, we went down by 4, so we did reduce to 40 at least. You know, a really good number is probably 32 if you can get it down to there, but for older hardware, basically, it's good. But yeah, we'll see. But yeah, so I guess it's good to know that I decreased the VGPRs by 4, therefore reducing the amount of VGPRs. So, but we'll keep it in just for a second because I do want to do a bit of a performance test. If what happens if we add more shapes to the switch statement? Because we've got this big switch statement in here. That switches over all the different types of drawers. And what happens if we add more shapes? How does that change performance? So we're about 0.53 ms. So let's go and get some more shapes. So let's say we could do a line segment. That's quite. One with the line segment, is there a thickness to it? Oh, there is, good. Double B is. Oh no, minus thickness is on the end. Right. Cool. Yeah, let's roll with some. Let's get a line segment one in. So we'll do the line. So we have to add this one in. So we need to read in a matrix, transform from command space to shape space. Read out the inputs. So the inputs is going to be crap. Yes, point A and point B. Point on the screen, I guess. Yeah, it should be fine. Actually, I don't know. Because P would be your pixel relative from the middle of the screen, or the middle of the shape. Maybe that's not the line. A line is quite handy though. Right, so the thing is about the line then, how we're going to do the inputs. So the way you typically do it is you say, you give it a center position. You give it to yeah, okay, I think let's just I think we can do it. It shouldn't be too hard. So we need like A or start position and then like an end position that we read out. Something like that. So this would be like sub f32 times 2. Same thing again. What's H? Oh, H is there, good. Right, so clamping, what are we clamping? Are we clamping scalars? Okay, that's good to know. Dot f32 times 2. Then clamp f32. Right. So this would be multiplying a scalar with a float 32 times 2. And then we need to do a sub, something like that. Cool, so that'll be our distance value. So distance, and then we can plop that on there. So let's go and design the API for that. UI H. So let's say draw shape line. Now, so center position inside the command space. That is. So what we should probably just say like is start position command space and then end position command space. And then you probably want to have some form of thickness. Which we'll bring in as well. So that's a single word, please. Then we want to say distance minus equal thickness. Something like that, yeah. Okay, so with this, we should it's typed. Right, so yeah. So this is where we upload the command, the data basically. So we want a line. Very nice. Now the thing is, we need to have a center position here. So we know how to translate it into the space of the shape. So I think these are going to be Yeah, I think they've got to be read in shape space. So uh, let's see. Yeah, a plus b divided by 2. Yeah, that's basically it. That'd be the middle. Yeah, see, I would have thought, yeah, it's the easiest way of doing it. Yeah, I would have done something more complicated. Thank you. Hey there, Chris. Welcome, welcome. Yeah, I think, and then we managed to translate these buggers to shape space or something. Uh, center which would be that the molars. Right, so there's your center position. What else do we want to do with this thing? We probably want to um, um, right, so I guess we'll upload the parameters. So we need a start position, end position, and thickness. So we need to translate them into probably shape space, because the way this seems to work is it's taking like it's relative from this position which is in um, coordinate shape space. But if the positions are all in, I could just apply the matrix to all of it anyway. Um, yeah, why don't I just apply the matrix to... I could apply the matrix to these two, but that might be a bit overkill. Shapes a command matrix. I have it here, so I can pre-apply it. Oh shoot. That's the wrong way around, isn't it? I need the inverse matrix. Oh, A and B. Oh, good one, thank you. Thank you, sir. So I need the damn inverse matrix to take it from because this will compute the command to shape matrix. I need that. So what I'm gonna do something a bit hacky. It's gonna be legit. We'll get the next pointer. Sorry, core stack. What sort of core stack functions we got? Get back. No, I ain't gonna do it. So it's index to the end of the array, like a boss. Now we've got our command to shape matrix, so we should be able to turn them into... So we should be able to say something like UI matrix mol v2 command to shape matrix start position end position, and then the float 32, which would then be the thickness. Right, so those are all the ones we need. Bearing in mind we need yeah. So then what we can do is we just need the command space ones. So I think we want to take the absolute of them. ABS of and ABS of end position. Whoops. And increase the draw commands access line bounding box by that. So that should be all we need, I think. So if we compile it and then run it, what I want to do is see if our shaders got slower. So it was at 0.53 ms. We're not even going to use this yet. We've just put the code in for it. Let's see if it gets slower. Right, that upped to about by about 0.03 ms. Why did that up? So I'm going to run and get some shader metrics. See if we right, so it did increase the number of VGPRs, right? But so simply adding another switch statement increased this. What happens if I reorder it down to the bottom? Right, so that dropped to 0.01 off it, basically. So I think what we need to do is we need to order it by most popular, because I think it's generally going over and doing a comparison on each one, basically. So that's something to think about as well. Hey there, not so red. How you doing? So something to be aware of, right, is the more of these switch statements we add, the worse performance we're going to get, even if we're not using it. So that's something to definitely be aware of. So I guess let's just try this, write a little test thing in for this one. We'll have a little line that goes up and down each end or something like that. Right, front to back. So just put it at the top. So move the command to about halfway through the display. We'll do a nice line. We'll say negative negative 400. Do another one to about positive 400, and then like down by up by 250. Then we'll add a thickness of 42 to see how this line works. Wait, it can't make it blue. Let's make it green. Hey there, Psycode, how you doing? Would it be possible to replace switch statement with an array of functions indexed by type? Unfortunately, you don't get function pointers in shaders, which is a shame. So you see that did work, which is pretty neat. But the bounding box is clipping it. So why is it clipping it? That is because we need to increase it by thickness. Add S. Yes, I don't know how I could increase the switch state performance really. You don't get... Yeah, if you don't get function pointers. There you go. Today I've got a line. So that seems to have worked fine. We made the command be this at the center of the screen. Then we just said negative 400 pixels to the left, positive 400 pixels to the right, and 250 up. And that seems to have drawn just fine. I'm happy with that. But yeah, that's added. Taking some performance there, I guess. See, lines aren't the best thing to draw either. Hey Perry boy, how's it going? Missed you, Perry. How you been? Hey new people, welcome. Right, so I think that's something to take note of. Oh, Psycode, I also managed to reduce the VGPRs even more. So something I discovered at the end of last stream is that we had a continue statement to try and skip the clip. So we got a clip shape. So yeah, if we have a clip shape on the screen and the pixels outside of that clip shape, you might as well just not bother testing any of the sign distance fields and we hit continue. But then it turns out that was increasing the number of VGPRs for some reason because it probably introduced inactive lanes and all sorts, right? And maybe divergent loops or something. On the divergent loops, I don't know. Divergent axes, memory axes. That's what I meant to say. So then what? So then I looked at the VGPRs and it reduced it. So then I thought off stream that we actually have one of them for the draw command. So each draw command on these guys. If the pixel's outside of this one, we continue it right now as a performance optimization. But if I remove that, it reduces the number of VGPRs down to 38 from 42. So we're nearly down to 32, but we moved down another layer, another block of VGPRs to 40 VGPRs now. So it's better. Yeah. Yeah, it did. Yeah. So it's another block of VGPRs. So it's good. I'm happy about that. So we are going to remove this though. I only put it back in temporarily so we can do a performance test of what happens if we increase the number of switch statements, and we've discovered that now. It does. The more cases we have, the worse it gets. So that's just something to keep an eye out on, basically. Hey there, Pro Boy. Good, thanks. How are you? How's that one mum doing? Yeah, they're doing great. You know, he's growing a lot. He's 2 months old now. Wait, it's right, isn't it? No, 1.5 months old now. Let me do some maths. Yeah, he's 1.5 months old now. He's nearly 2 months. But yeah, he's has had some like stomach problems, so he's been whinging a bit today. He had some gas the other day, so hoping he gets over that soon. We've been trying to give him some stuff and all that, but yeah, I think he's just got to. We think he's got to come off the formula milk basically. Like we only feed him at some time, but I think he's just not doing him well. Did it impact performance? It made it far worse. Oh, wait. Yeah, removing this made it far worse. It made it 9 times worse, but it's fine. When we do the tile-based renderer. If you're talking about the switch statement, if we add another switch case, it increased it by 0.03 milliseconds. So increased it by 30 microseconds. Oh, the continue, good. Okay. Yeah, increased it by 9 times right now, so fine. We put it back in so we could test performance. Hopefully it sorts itself out. Are you back at work now? Yeah, so been back at work a few weeks. Yeah, I've been back a few weeks. But yeah, I got straight back in and it just came back in, fixed tons of bugs on the code base. Because I came back and my boss was just unloading like 9 different things. So I got those done. Now I'm back on my main task and thinking super hard and yeah. But yeah, it's going good. Going good. How's your work? How's work going for you, Perry? Well, that's the thing. This is a temporary performance increase, but the title of the stream is tile-based renderer. So we're going to be breaking it out into tiles. And I probably want to get started on that, to be fair. Like, I could reorganize these and try and squeeze out another, okay, if I move these AABBs and circles up to the top, right? Wait, what sort of thing we got? Yeah, 0.5657. If I move these guys up to the top, they use that all the time. Guaranteed we'll get something better. No, no, we didn't. Okay. Maybe because there's a bunch of unions and that going on as well. But fair enough. My mistake. I don't know what's going on. So as we increase this, it gets worse. I don't know. Yeah, if we bucket into tiles, that alone is the discard, right? All right, let's just get started on this because it's going to be fun. Yeah, good, thanks. Currently run a load of low-level design documents, which is fun. Yeah. Crazy. Yeah. I've done some like big old designs before and done designs up front, but it was very much like high level. And I sort of maybe dabbed into some sort of low level bits for it. But doing like a big old one, which is tons of detail, seems like a lot of work. And it seems like you have to know exactly what you're doing, right? Okay, so the biggest problem right now is that we have get creator open. Look at that speed. Right. We have like, this is a draw command, this is a draw command, this is a draw command. Every one of these guys is a draw command. And per pixel is going over all those draw commands. So obviously this does not scale, right? It doesn't scale. So how we need to fix this is we're going to bin them per tile. I don't know how big the tiles are going to be. They could be as small as 8 by 8, or they might be as big as 64 by 64. It depends. So the idea is we're going to split the screen into tiles. So we'll have a pre-pass, which is going to run over every command and every tile, and then bin it in it, right? So these are obviously horizontal, but give me a minute, I can draw it. Stuff like this, right? We'll have these are very horrible drawings, but you get what I mean, right? We're gonna have square tiles. They'll be square, I promise. And now here's the beauty of it, right? Is at the end, if there's no draw command in a whole tile, we simply won't even bother drawing these pixels, right? So we'll be doing that as well. So the basic idea is you know, there's not too many good examples here, but well, there is actually. This whole background is actually a draw command. That's what. But anyway, there's a test for the clipping thing. So this one here, this tile here, it will go over all the draw commands, and it will find that there's this one and the background that both can be drawn for this group of tiles. So it'll basically create an array for that tile where there's a list of 2 draw commands. And then when it goes to draw these pixels, it'll go over that little array and then it'll be done. Right? So if you have thousands of draws, it just uses the little list that it's got on there, right? So this is great and everything, but there's kind of an issue. Yeah, there's kind of an issue, and that is like you don't have dynamic memory allocation on GPUs. So if you were to have like put tons of layers down over a single group of pixels, you can fill up, like you've basically got to either like link list these draw commands, or you can have a fixed sized array, right? But the answer we're going to go with is both, right? So the pros of having a fixed size array is there's basically no allocate. There's no, like, it's contiguous in memory, therefore it just gets loaded into cache and it'll be super fast and smooth. The advantage of the linked list though is it's scalable, meaning if you were to have a problem where you fill up the array of draws that go in this tile, you can just allocate more individual nodes and then off you and link them together and off you go. But the issue is obviously the memory is not linear, so it's just be jumping all over the place. So what we're going to do is we're going to combine the two things, and we're going to have essentially like trays of 16 entries, which can hold 15 draw commands, and then the last one is going to be a link list index. And then so that this means that basically every pixel will be fixed allocated, but for the cases where there's something ridiculous that happens on screen and we can still afford to render everything, it can do the link listing thing once and then load the next tray of draw commands in. So I think we'll roll with that method because it'll be fast and it can scale as well, and we don't have to just go, oh, you've hit 15 or 16 tiles, 16 draw commands in a tile, and then the only solution we have is basically crashing or stop rendering after 16, and then you start getting glitches, right? So this is basically what we're going to be doing. So I have a pre-pass which bins it in a tile, and then we probably want to be able to say, hey, if this tile actually has anything, add it to a list, and then we can do like a draw indirect, dispatch indirect, and then only dispatch the tiles that actually need to be drawn. And so if you only have UI on part of the screen, you're going to only color in parts of the screen that you need to color in. So that'd be super, super sweet. So let's get going on that one. Yeah. Yeah. It's probably, yeah, 8x8 or 8x4 is probably good if um yeah. The thing is though, it just gets a lot of memory, right? So if you imagine like there's 240 tiles across times by two. So what did I do wrong there? Oh, I did divide by 4 instead of 8, right? Times 240. So it's 32,400 tiles. That's a lot of tiles on the screen. So if we double it, we can reduce it by 4 times. So we did 16 by 16, that's 8,000 tiles. Is that a lot of tiles though? Say we had like a tray of 16 elements per tile. That gets you 500,000 times by 4 floats per, which is 2 megabytes of memory. This might not be a lot, is it, really? It's 2 megabytes of memory for that. It just depends, right? Okay, so let's make the shader that does it, and we can always change the number. And we can just see what's better, really. And we'll do another test scene, because this scene's pretty... It's not good... It will definitely show improvement, but yeah, it will just... We can... Yeah. Do something else. So we need a new compute shader. So this time we probably want to go over... Like, each thread gets a tile. No? Gotta think about that. Tile binning or something like this. So the idea is we can go over 2 different ways, right? Every thread can go over, could be a single draw draw command that goes over every single tile, or it could be a single tile that goes over every single draw command in a loop. So what you kind of want is you want to minimize the amount of divergence in the threads, right? So we'll probably just make this like 32 1D. And then so we go over, so if it's a tile, if we do this one tile here in screen space, whatever, that goes over every single draw command and checks whether it's inside the our bounds, right? And then it adds it to a list. So it adds it to a list, and then at the end, we could, so there's a tile that goes over every single draw, we could then see if there was actually anything. If there was something, we could then, or if there wasn't anything, we just end the shader. If there is something, we can add it to an array, atomically add it to an array, which would be a tile location. Yeah, I think we'll do it that way, because then you won't get any... Oh, no, but the problem is you'll get divergent in a loop. Yeah, so this one you'll say like for every one of these guys, and if the answer is true, you will get you'll get a bit of divergence there. You'll get some inactive lanes, which could be okay. But then at the end, you can do that thing where you say, if my tile as a whole has actually found something, then it can go onto a list, and those are the things we'll actually render. So there's the benefit of that way. The other approach is having you get one draw command per thread. This one means you go over every single tile, and if successful, there needs to be some sorting as well, actually. You need to sort from front to back. But maybe that can be done in a separate pass. It's not really a big problem. Right. Yes, the other one is you want to the other one is go over every single tile, and when you find one, you add it. So essentially, it might actually be better to not clip at all and always execute the slow path with the tile approach. Yeah, that's what I'm going to be. Yeah, that's what we're going to be doing. Yeah, we're going to remove this. Yeah, that'll be the hope. It should be far better. Yeah, so the clipping, so the only type of clipping we'll get is the nice sort of like advanced clipping, basically. Yeah. So the problem is we have to insert them as well. Yeah, I think it'd be better just to go. All right, I think we'll just write it in a certain way, and if we find it's. Wait, so if you're going over, if one thread gets let's just test this thing. If one thread gets a draw command, each thread gets a draw command, and they all go over the same tiles basically and check if they're in. It could then be added to bind to the tile. You'll get divergence there. Actually, you won't have to worry about sorting them because they already would be sorted anyway. So you're going over them from front to back anyway, so you'll be inserting them in the right order, so that's fine. But the downside is at the end is you would have to do a separate compute shader pass, which goes over every single tile and checks if they... Anyway. Yeah, I think there's basically no difference, except for the way that we thought of first lets us do... Okay, this is good. So we basically need to do a for loop like the very similar for loop. Why do we need sorting? That's how we do the alpha blending. We do front to back alpha blending. So we sort them front to back. We can do an early discard when we accumulate to 1 alpha. Something like this. So we do front to back alpha blending if we reach a fully alpha pick 1.0 alpha or more. We just finish. So yeah, it's a bit of an optimization as well. Pretty cool. So all we need is the... I'm not sure what we need though. We're doing tiles, aren't we? So what are we trying to do? 8 by 8. What is the game about? Absolutely nothing at the moment. That's what it's about. We're just building the sort of, we're doing some graphics R&D first. So the first bit of graphics R&D we're doing is this UI. We're going to get some UI in for the game, so we'll be able to get some debugging features in, like little debug panels and ways to sort of like edit things in the world and save it out and have a nice UI. And then we'll be doing, after we've got the UI thing, we'll be actually going to do some graphics some 3D graphics R&D. And then from there, we'll actually be doing some research into what game we want to make after that. That's the plan. Pull your commands into SSBO. Ooh. Put all your commands on on a buffer. In a different buffer with fixed sized array for each bucket. Yeah, we're not doing fixed sized array. We'll do a linked list of them. But yes, very similar. Very similar. We're going to link list arrays of 16 because otherwise, yeah, it's a fixed size linked list basically. So there's so we went over this a second ago. We're gonna say there's 16 entries per tray, and each tile gets a tray when it needs it. And when it fills up a tray of 16 or 15 or whatever, the last element points to the next tray. Right, so this means that it can handle the problem where you fill up too much and still get the performance. But what do you plan it to be about? Nothing yet. Nothing yet. It's 3D. That's it. I need to find like, because I have so many like different ideas it could be, right? But I want to like dedicate and focus when I have something where I can actually start using it, right? And after I have something visual in and the visual style that I want, we can then turn it into a game. So yeah, so I guess we'll go over a number of tiles, right? So we'll have like an tile dims, we'll call it. So this is how many tiles we're going to have. Yeah, it's kind of a linked list, but it's not. Yeah. So it's an array. It's got an array of drawer IDs, and then the last one is an entry to the next array. That's the way I would do it. So we've got a coordinate on the screen. Wait, do we need a coordinate on the screen? Wait a minute. It's a tile coordinate. And we probably want that as that anyway. But we will want like a... Yeah, we do want it as a float actually. Right, tile coord. Right. We should probably have a constant now. GFX UI tile size. 8. Something like that. So we'll go over all the draw commands. And we've got this lovely sort of like screen pixel to draw command matrix, and we have our half dimensions. So we can do this here. Shoot. Tile coord. So tile coord in draw command space. And then we just do a bounds check in there. Bearing in mind we should change this into pixel. This needs to be a bounds as well, doesn't it? Yeah. So we need a... what do we want? Should we translate a whole axis line bounding box? Yeah, we should. So do like an add or mul. And then, so that's sort of like the sort of minimum and maximum. Now, the thing is we're working in... We'll be translating this back into sort of like draw command space. Can't use tile ID in your compute command. If so, would it be better to use tile ID as an index to the draw command? Yeah, but I can't do a fixed sized array. Like, I don't know how I'll be able to do a fully fixed... Like, it's going to be a fixed sized array. Put it that way. Let me... Yeah, if you could draw, but I don't think... Yeah, I think I've... Because the problem is I'm binning it... Multiple threads are checking every tile and they're trying to add to an array somewhere. So to make that contiguous, you basically have to pre-allocate the array. Right, that's the idea, right? Pre-allocate the fixed sized slots, but we are... Yeah. In the max. I haven't written the allocation code yet, but we are going to be pre-allocating fixed sized arrays. Yeah, we're going to pre-allocate fixed sized arrays, but they're just going to be a way to link to the next fixed sized array if you run out of room. Because we don't want to have the problem where if you draw one UI element on top of the other UI element and you've run out of room in your fixed sized array, and what do? You basically can have to stop rendering or spawn the renders. So we might have a way to link list it, but then again it's going front to back. So we just support up to 16 layers, it might be fine, right? I'll think about it. Oh no, it's just better to do it on the GPU because then you can multi-thread it. Or is it better to do it on the CPU? No, because then I have to do all the maths on the CPU. It would just be better just to bin it in the GPU because it's all going to GPU memory anyway. You don't have any of it in screen space. So you have to transform it into screen space, whatever, and bin it. Yeah, I think it'd be better to GPU. It'll already be going up there. So when I add to tile coord min, something like that. So the thing is, we want to basically do 2 bounding box checks. So one is so essentially, let's get Milton out. So the thing that we've got to check is this, right? So we've got origin 0, 0. Let's put that as a dot. We've then got the a vector representing the half dimensions of the box, right? So we've got half dimensions of the box, and then we've also got a tile min and tile max. So we're going to translate into this draw command space. This is draw command space. So say if the tile goes over like that, how do we represent this best in order to do this check? We could check if it might just be a standard. Maybe just a standard ABB check, I think. But we can maybe simplify it a little bit because the distance to the center or whatever it is you don't have to take away because it's already in that space anyway. So right, so because it's an access line bounding box, we can absolute it, right? Absolute this, and then check to see if, yeah, something like that. Hey there, Buff Overflow, how you doing? Welcome, sir. So yeah, I think we'll be able to then ABS this guy. So I think we'll have it as tile size in screen to whatever. Yeah, so we'll do another one. See, that includes a translate. That's the issue I'm having with it, you see. So I ideally want to... That's really be like mol p2 maybe, because that includes translation. Oh my days. Right, let's give it a rename. UI matrix mol p2 for point. Whereas we want to have mol v2, which is not going to do this add at the end, right? No translation, please. So we want a v2. And for that, we can just get the size of the in command space. Yep. Tile dims in draw command space. Do we want half dims? I think we want half dims, isn't it? So which means we probably want to have a center coordinate. UI tile size divided by 2.0. Something like that. Nice. Very nice. Oh yeah, super effective, damn straight. It's just pouring at me naturally now, you know. No, it's the type of stuff where like I don't do it for a while, I'll forget it, and then yeah, just go into mass mode. This is part of why, you know, that question earlier, like what game do you have planned about? It's like, well, you know, I want to get into the mode of planning that thing and do it really well. So yeah, I'm waiting for the opportunity to sort of hyper focus and pick up the different hat. The you know. So right. So we've got the center coordinate of the tile in such a long variable name. There you go. In draw command space. So we've got the half dimensions. So basically, what this vector and whatever. So we want to then now we'll just do some proper like mathsy things, right? We'll call this one P, and then we'll say like that. So we've absoluted this vector, which is representing a point relative from here, center position of this guy, right? So that's been flipped into here now, right? So now you got this here. So now all we have to worry about is something to do with. Now all you have to do is worry about the dimensions or something. How does one figure this thing out? Well, the easiest way is Google, right? But yeah, so you want to like, so we've got the dimensions of this and this. If we take away the dimensions from if we take away the half, yeah, if we take away the half dimensions, and then if it's inside here, then it's a hit. That's it, done. So you get your half dimensions here. So you take that away from P. So you're gonna do like a sub. And now the simple check is if all crap, what would it be? Be a ball to, yeah. So I'm gonna say if less than f32 times 2 less than or equal to P and what's the dimensions? Draw command AABB half dims. Magic. So if all of those are less than or equal to, then we've got ourselves a hit. So now this is where we are going to add it to an array, but we don't have our array yet. So, right, let's just imagine we've got a fixed size solution for now. Yeah, let's imagine we've got a fixed size solution. So we'll just pre-allocate everything. So let's just say you've got your tile commands capacity, say there's 16 layers at most. So what we're going to do is we're going to have another buffer somewhere. Now, here's the thing. Yeah. So we need to get our sort of our tile index. That is going to be your y times dims times point A plus this, right? So that's your tile index. And what we need to do is have another buffer somewhere. I haven't got this thing sorted out yet, but there's going to be an array of draw commands. And you're literally just going to yep. Oh no, sorry, not system values, BC. So it'd be something like tile draw commands, and we're going to say tile index. So we don't really have the number yet. So we're going to have like draw command, tile draw command index equals 0, and we'll just increment this guy. So it'd be tile index times. Right, so I guess we'll pre-do this one. So then we'll say like tile draw commands start index. That'll be tile index times by, wait a minute, that should be a 1D thing. Good. Draw command capacity. And then we can use this in here. Plus tile draw command index. Now this is something we're going to increment here because we've inserted it. And then we want to then plop on the draw command like that. So with this draw command that we've just taken from this draw commands list, where there's tile draw commands, we're just going to put it in there and then increment it by 1, right? Now the problem is you've got to handle when you fill up the array. So when you fill up the array, yeah, so we've got to say if this, okay, so when we've finished, yeah, if this is equal to a GFX UI tile commands capacity, maybe it should be called tile draw commands capacity, right? Then this is where we've actually finished, right? So we're sorting front to back, right? So ideally, if you've laid up 16 draws and it's in front to back order anyway, over the same pixel, over the same group of pixels, surely, you know, hopefully the 16 all sort of go over the same pixels, right? And hopefully there's no gaps, and hopefully as well all the sort of 16 that you've drawn are fully opaque and not transparent and require alpha blending and still be visible, right? So that's the hope. So you fill up the array, then break. So now the shader's basically done, but we're going to need one more thing, and that is if. So this is a further optimization where we want to do draw. We now want to do a dispatch indirect. So what we're going to be doing is saying, well, what happens if your tile, bear in mind it's meant to be square. These are all just because I drew quick. If your tile hasn't got any draw commands in it at all, well, then we don't need to render it at all, these groups of pixels, and even launch a shader to begin with, because that requires the GPU to schedule this, and it does take time. And if you have like 32,000 of these guys, and half of them don't need to run, that's a number times thousands. So it maybe starts to show up then, right? You know, when you start times and stuff by about 1,000 or many thousands, then things do start to show up, right? So in that case, if you have something like this, we'll do a lovely atomic add. So on atomic, See, I gotta just quickly figure this one out. Third party HCC, libhcc intrinsics. There's an atomics, right? Yep. So atomic add. Yes. So I want to do an atomic add U32. We're going to be adding into a buffer. So there will be a buffer in BC. We'll call this one tile. See, the problem is I need this somewhere. So I might stick it right at the start or right at the end of this array. Because I just need one word and it's done putting in a whole buffer, separate buffer. We can reuse another buffer. But we're going to be... Oh no, we'll do it in this one. Right. So we'll say tile... So you can turn your tile index into something 2D, can you? I think so. Yeah, so we'll call it like tiles. And at the start of it, that's where the special word is going to be. So we'll have this sort of tiles count index counter index tiles, something like that. So that's with a special tiles buffer, array of tiles basically. So we'll just then say, hey, this one, wait, what are we adding? Adding one. And we get back our index, right? So this one would be tiles. And then we insert into tiles, insert index. And we insert the tile. See, we could do a two-dimensional thing, right? Because you're not likely going to have 64,000. So two things we can do, right? We can avoid passing in tile dims into the other shader. But I want to do some debug drawing for this so we can see the tiles you see. So we'll probably upload a tile. No, but the tile dims are constant. Why am I being a silly person? Look at me go. So it really doesn't matter. It's just multiplies or whatever. So then that would mean we can just pass in the tile index and then we can just convert that. Well, no, because that would require mods and divides and stuff. So we could... What can we do? Well, we could pass in a 2D coordinate. Just packed. But then you kind of need the tile index anyway. Yeah, we'll pass it in packs. So we'll say ucoord .x shift left 16 ord with yeah, ucoord.x. Right, obviously we'll get in these guys like that, and voila. That will be good enough. Right, so that's basically everything we need now. So this is our tile binning shader. Now what we want to do is get in everything else around here. Like, because we've just written the sort of logic, or we haven't sort of set up the buffers and other things like this. We also need to know how many to draw indirect on, basically. Yeah, we need to fill in an indirect buffer or something like that. I don't know how we'll do that. Okay, for now we're not going to do dispatch indirect, but that's the we'll do it later. But for now, we're just going to be getting it working and seeing the benefits, right? So this one is going to be known as the tile binning. So the tile binning, what do we need? We don't need any output textures. We need the draw commands to come in. We need the draw words to come in as well, because they're all the draw command points to a range of words, and you sort of pick off the words as you need them. They're just arguments, basically. We don't need any clipping stuff. We do need our two new arrays, right? So it's these tile draw commands and tiles. Tile draw commands, that's going to be one of these guys. And then an array of tiles. It could be called like a tile list. Tiles list is probably a nicer name. So that is basically it. Draw commands count, we need that. Yep. This is running think and go. Oh, no, we need that is running because the break will make it slower. Right. Pretty good. Okay, so let's get the CPU side of this thing all sorted out. So if we go into the GFXC, and so before we run any... So we basically just want to launch another shader, right? So we need the draw commands, we need the draw words, we need a new one called tile draw commands. So we'll UI tile draw commands buffer ID, we'll get that initialized very soon. We need another one called the tiles list. And we need nothing else. Ta-da! Now, this will be known as the tile binning. So we have, so what we do is we run two compilers, right? We run the custom C compiler for shaders. That's going to output an enum. It does some code generation and outputs stuff like an enum and some other things which you could use for sync code, but we don't use that yet because we just did it manually. It's fine. But yeah, so that enum will be filled in when we compile successfully. Now, what do our local dims want to be? So we basically want to divide it into tile. Wait a minute. Right, so now we get to think about this again. So I've done 8 by 8. So that's saying like local size would be doing 8 by 8 tiles, which means you need to break. So you're doing 8 by 8 tiles. So you need to divide it by 8 and then divide it by another 8, or the tile size, whatever. Something like that. So if I had like 1920 divided by 8 divided by 8, right? And if I had that, but if I did divided by 64, is that the same number? Yeah, good, okay. So I could just multiply it. Maths. Cool. So take the display width and display height. We'll do all that jazz. We need to make sure we multiply this by... So then we upload a little bundle constants to the GPU. So remember, they're only a small list of stuff, right? So now we just need to initialize these buffers. That one and that one. Then we're going to go and initialize these guys. So here's where they get initialized. So ggfx dot. Right, so this lovely buffer initialize. Now, and tiles, right. So this one is the UI tile draw commands. So how many do we have? Well, we want to say, so we need to kind of know what's the most number of tiles we're going to have, right? So U32 tiles cap, what is that? Well, let's say the maximum screen size will support. So we should probably have this somewhere. So we're like a temp, whatever. Right. So we'll probably call this like, you know, max display size. Let's just do like 4K, right? See, the problem is if someone never makes their screen 4K, it does pre-allocate to that anyway, but I don't know. Anyways, stuff we can all, you know, if we figure out, oh, we're taking up tons of RAM here for all this stuff, we'll just change it, right? No biggie. So tiles cap equal max display width times max display height. So that's in pixels, but we're talking about tiles here. So you then want to divide this one by, now this needs to be like in a sort of shared context, right? No biggie, we have that between the CPU and GPU. Tile width times tile height, yeah. That's what we need to divide by. Yeah, we need to divide it by the tile width, tile height. But I think it must be divide round up though. So the tile width is always square, so we just square it basically. But yeah, we do have to. The problem is though, is you've got to fit, like if it's not directly divisible, you have to make sure that like it doesn't truncate, it's got to round up. So we use our lovely sort of divide, round up. Macro, which does all that silly business for us. There you go. So that's the maximum number of tiles we're going to be having. Probably quite a big number, but it should be fine. So that will go in. So for tile draw command, it's tiles cap times by GFX. Right. It's probably quite a big number, but we can look at this now. So it's times, right, so 16,000 divided by 64, because that's 8 times 8, right, which is the tile size, It gives us this number here. Then we times it by 16 per tile. Right, then times it by 4 floats. And then we're back to that number again. Sorry, times it by 4 bytes per float entry. Wait, no, it's not even a float, it's a 32 integer. Anyway, 4, yeah. So 16 meg. So 16 meg for that buffer. That'll be fine. Then we've got a tile list of tiles. So at most you can have every single tile, right? So it's just tiles cap. Yeah, it's not bad nowadays. Imagine the old days. That would have been pretty bad. What's this distro use Manjaro? It's basically Arch Linux pre-setup, and they delay the updates, so if there's anything breaking that goes out, you have less chance of getting it. You get sort of the latest software, basically, so it's good. Tiles capacity times by, so it's an array of tiles. Now you do have to be like +1 to be enough for the extra count that goes at the start of the array that's atomically incremented. Basically. Cool. So this is there for the draw indirect or the dispatch indirect, which we will do later. Right, so those two things are done now. Now, right, so you think we might be done, but we've still got a couple little things to do. We have to synchronize on some resources, people, manually, because we've cheaped out and made the graphics backend really quickly. So there's some manual stuff that you have to do outside of it, which is not a big deal. So although I have got the reflection information, so I could do this automatically, but anyway. So actually this one is read only, this one is write only, right? Write only, and then this one is read write, because it does an atomic increment, right? Cool. Rightio. So the next thing to do is to synchronize on these lovelies. So all these guys we need to sync. So BC draw commands. Oh. Okay, I guess that would work. So this one is read only. The words and the tiles. See, so it's not that much of a pain because I don't know how many shaders we're really going to have. It might not be fun to manually write this stuff out. So read only, write only, read write. And we kind of need to do that below now. So the way this system works is you say, right, synchronize on this one, synchronize on this one, synchronize on this one, blah, 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 right. And it's going to, in the background for each of those, basically keep track and like, wait a minute, what does it do? Yep. So what it would know, it would already know in the background if in a previous shader it has been written to. So if you say on a read from it, it goes, hang on a minute, something before this was writing to that thing. So you're going to have to wait until the previous one is finished. So when you do your next dispatch, it puts in the pipeline barrier in Vulkan terms, and then it will do the dispatch afterwards. The pipeline barrier will say, hey, wait for those resources to be done with, that sort of thing. So that's all it does. So we'll have to do the same thing here. So we already do it for the surface, which is the swap chain surface, anything you render to. So we need to do it for the draw commands. See, we don't really do it for the draw commands buffer. These guys, we know they... Well, they could have been uploaded to, actually, which means you might need to do... Yeah, we'll keep it in. We'll keep it in. Words, clip words. So we're going to be needing something else, but you know what? We're just going to run the binning thing. We're not even going to get it plugged in yet. But I want to see it running and see what sort of perf performance it is, right? Because we've got a little perf thing in here. But these will all be read only. But obviously we'll be adding these tile list and tile draw commands buffer into here as well, which we've been writing to. So it'll put a hard barrier in between these two, right? So let's compile everything, and looky here, it compiles. There you go. So, right, as a warning, if the stream shuts down, it's because I got GPU crash. We sometimes get these because it's because we index our buffers on the GPU, and if you pass in a weird index, it will like just blow up the desktop, and yeah, so it might restart. Oh, I forgot something. We need to reset the atomic integer. Right, so hold on just 1 second. So we see here where we increment this in the tile list. Well, we need to set this to 0 somehow. So you could set it at the start and then do like a barrier, but we already have this thing called a frame init compute shader, which just does that. Right, it runs one thread and just initializes everything. So what we want to do is have this tile list placed in here. Yeah. See, we could have made it a constant somehow, maybe. Maybe we could have made it a constant ID, but anyway, it doesn't matter for now. Right, so we need to set this counter back to the initialization, which would be GFX UI tiles start index. Cool. So that means it will start on 1 instead of 0, otherwise it will overwrite itself with some big number and then it'll just be wrong. So we need to quickly, so this could cause a crash, so we need to quickly do that. Yeah, so BC, where is it? And then we need the tile list sync on it as well. Write only. Write only, please. Yes. And there we go. Alright, so let's hit compile. Let's take that for a spin. Okay, it could crash. If so, I'll be back right in a sec, but let's see. Ready? And go. Right and crash. Voila. So that tile binning takes 0.01 ms. So that's only for 16. Wait, no, 16. That's only for 14 draw commands, right? Because there's 13 here that you can see in the background. That's another one. So that's doing the binning for us. I don't know how well it's doing it, but it's doing the binning. So the next thing that we want to do is do some debugging and actually see the tiles. So I think we want to bring these tiles in to do some debug drawing. So we'll bring in the tile list and the tile draw commands. Something like that. So that'll just go here like that. And then we need to do the sync code for it. So these two go in here like this, but these ones are read only. Right? So they're marked as read only. Like that. So now we've got those in. Wait, how many have we got? One, so 4 bytes, 8, 16, 20. Wait, no, sorry. 4, 8, 12, 16, 24, 32. Yeah. 36, 40, 44, 48. That's fine. We can't go any more than 64, because if we're any more than 64, we've got to maybe change stuff. How far can you get with a web browser compiler? Basically nowhere. Like, I'm not sure what you do. You mean like compiling for the web, like to WASM? Like we don't support WASM because it's basically like we do like so many features that are just not on web because it just makes the code base simpler. So we want to try now. So what we want to do is right. We actually have a list, a tile list. So we could theoretically read. We can read from there anyway and just not do the dispatch indirect to reduce the number. So we'll have some which run basically nothing. You've been using WASM, it's annoying. Yeah, there's stuff to do like memory allocation. There's stuff to do with like graphics APIs as well. Like if you use the sort of more legacy APIs, you can sort of be fine with it. But you know, and there is obviously web GPU, but that's still you got to use the sort of legacy thing, basically. We use more newer features really. But yeah, it's there for most people, but plus I'd rather people just sort of play the game on a proper desktop, you know, and not through like a web browser. Hey there, Davros, how you doing? Welcome, welcome. How's things been? So yeah, I think what we can do is we can pick up a tile. So we've got to base it on the dispatch index, isn't it? Or the so right. Luckily, I've got some comments here because past me is like no one will understand this, so it's all written out in nice English. So dispatch index is the, you know, if you just to go over the whole screen of pixels, it's the pixel. The group index is the dispatch one. So say if we go over a bunch of tiles and the local index is the pixel within the tile. Yeah. So this would be the pixel within the tile, and this one would be the tile index 2D. But then again, we could also do a 1D coordinate anyway. So we could just say 32. Oh no, 8 by 8. And we'll only need the group X. That's your tile index. Your tile list index, call it. And then this one will be. Then use your local. Your local index will be your pixel within the tile. So what we want to do is we want to do a load. Now it doesn't have to be an atomic load anymore because it's already been synchronized. So this gets you the number of tiles. Tiles count. If tile list index is if that is greater than tiles count, then we'll just return. Wait, would you ever get that? Yeah, because we don't know how many there are right now. So we're just going to be launching like far too many. But we should be able to get a perfect number, really. Yeah, let's just do a fixed number for now. We'll just hard code it some, and but yeah, we really need to dispatch indirect here, and this can go. Then we get your tile. So we unpack the tiles. So tile list index, and this will be if we'll get a 2D coordinate back out. So here's our tile coord. Impact is 16-bit integer. Now I want to bring that out and packed tile coord. So you want to bring that out into probably a floating point number. Tile coord. So that'd be x would be and then packed coord shift right 16 will be the y. So that's quite nice. Now you want to work out your actual pixel coordinate. So that's just coord. So pixel coordinate. See, I was just thinking actually, we've used the name tile coord up here as well. And it's different. Screen coord center of tile. Something like that. Center tile center position in screen space embedder. How long have I been programming for? 13, 14 years, something like that. How about you? How about you, Ozzy? Ozzy? Ozoig. How long have you been programming for? I really butchered that name there. Okay. Much better. "13 years. Nice one. Oh, 13 years question mark. How old am I? That's a good question. Always forget these things. 28. 28 years old. That's all I am. Yeah, also quite funny as well. Like my dad and me were the same age when we had our firstborn child. So, like, yeah. So it was quite interesting. You look 18. Thank you. Thank you. So you say I look 18 right now. Imagine how young I look if I shave this beard off. Would that be 12? That's why I never shave my beard off. Like I would like to keep my wife and child, and you know, so I keep the beard on. uh, when people like accidentally shave their beard off a little bit, like I would be the type of person who would just keep that. Like I wouldn't shave it all off. You know what I mean? Just I'll keep that sort of thing there and just live with it because it's that bad. Exactly. Yeah. Exactly. Yeah. Honestly, you're 6'6", and that won't be a problem. Yeah, well, I work from home, so I look uh, I look about average height right now to probably most people. Um, if I move the camera down there and I'm not looking down at you, then you'll be like, "Whoa, this guy's massive." So our pixel coordinate is a little bit of addition. Get that tar coordinate. Get that SV dispatch local index.xy, right? Bam. That's your pixel coordinate. We've got it back. So the idea now is that could still be out of bounds, right? So you really gotta like. Wait, is this a? Oh, okay. We'll keep an integer coordinates actually. Don't worry. Being silly. Ugh. Yeah. So u chord. Right, there you go. So out of bounds end, and then coordinate, and then we go it works. Now, right. So we've got to change the dispatch x. Now, hopefully this doesn't blow up, right? So now it's all about the dispatch x. So we're just going to be doing 1 across the y, and we're just going to be launching tons across the x. Now, you're basically got to launch how many tiles you have, right? So let's just do how many we have for our screen. So I think I've done like, wait, what's my temp thing? Yeah, so we'll just square this number, right? And that's the number of tiles. 1024, wait, times that number, divided by 64. No, divided by 8. 8 across. No, divided by another 8. Don't mind me being dumb. 25,600. Right, so that's the most. So let's just do like 30k. Now, I don't need 30k, but let's just do it. Right, so this is where again. Alright, that all compiles looking good. So this is where the stream could go bye-bye. Still. So when we run it, if it crashes, I'll be back. Until you meet them and they got humbled, yeah. Yeah. So I'm about the size of I'm a little bit under the size of a door frame. So I'm thankful that I don't have to duck every time I go outside of a door. Some people have to do that. And that is like really, really bad. Still though, like every like sofa is basically uncomfortable. I have to get like an army of cushions to sort of like support me. Because there's no not I can't like simply lay back and rest on it. What else? Chairs. This chair's good, right? Nice headrest, but some, you know, if you just go over someone's place, chances are their you know, tables, chairs, and that is not really built for someone your size. So you just have to kind of be aware of that, really. Airplanes as well, yeah. Like a regular seat I can manage, but the extra leg room is like so much more of a quality of life improvement. Yeah. Right, so the stream stops. I'll be back. Let's see. Does it crash or not? Right, it's still running. Good. We're getting some tiles at the bottom. Right? Now this shader is like bloody quick, right? But yeah, it can be quicker with it when we do a dispatch indirect, but we're not getting anything on the screen, so something is wrong. What is wrong? That is the question. So what we want to do is not run our shader at all. What we want to do is color in the texture and then just bail. So we're just going to be coloring it in. Now here's the beauty of it. We can do a random color. They're too small. Yeah, that's right. That's right. So we're just going to be writing a beautiful, beautiful color. So we'll say now radio. So what we need to do is do randomized color now. So the best way to do randomized colors is we basically need, so 2 seconds, we need to get a HSV to RGB. So we'll randomize on the hue, and then we'll just select a brightness and that we want, and then we'll just use that, and we'll be tiling it. We'll be randomize it based on the tile index, and then we'll see it on the screen. So we need to quickly get a GLSL HSV to RGB converter. And we'll convert this over to dump it in the code base. So this ought to be good enough. We'll go over to the shared code. We've already got these sort of like linear to static inline F32 times 4. So this is HSV to RGB. Now I guess we'll get the other one in here as well. So times 3 I meant, oops. So we'll do something like this. So that's F32 times 4 times 3. So fract. We've got a fract in our code base. Right. So we do have swizzling, but I want to make this sort of accessible across the CPU and GPU. So I guess we'll call it like just call it R. So we do have swizzling extension in the compiler, but yeah, we're just sharing the code, you know? K. So X, Y, Z. Where do we use K otherwise? See, if K is like that then, and K is always 1 anyway, They didn't mutate K. That's like take 1. Why? This could be simplified way more. That's just 3. Then this one is... I guess they were just thrown in there for... Right, just to get a bit of... Alright, that's fine. Yeah, don't worry, it's already pre-calculated. Like the compiler will... Yeah. Yeah, the compiler constant folds anyway. Like HCC actually does it. Yeah, so that's good. So fract, what are we doing? F32 times 3. Add F32 times 3. Then we're scaling it. So moles. Then sub S. Then ABS. Cool, so mix is just lerp. Right, so that'd be a moles. Color. Right, so that would be clamping. Okay. Let's subtract S and take away 1. Then we're clamping. Cool. Nearly there. So this is just 1 splattered out into a vector basically. Then this lerp is perfect. Right, so I can't be, that was a lot of effort. I cannot be bothered to do the other one. If I need it, I'll do it. No biggie. So we've got this guy now. So we can use it to randomly generate ourselves a so we'll have an if 0 here, I guess, and we can always enable this whenever we want, and it will just color the screen in based on the color of the... Right. So you get your sort of like... See, the silly thing is... this one has alpha in it. It's as if I need another version of it. There'll be a 4 version. Must be a 3 version. So we'll just remove the A from it. Ta-da. Rightio. Very nice. Keep the tunes going. So what I plan on doing here, well, what we want is the essentially the color, right? Now color is going to be equal to HSV to RGB. So you just experiment with SDF for UI after seeing cool. Vector graphics library. What are they doing? Yeah, but they're doing it in the shader. But yeah, that's cool though. Shield shape. Grid. Nice. Oh, there's a common library. Here it is. Yes, they're doing it all in the shader, aren't they? Yeah. Yeah. So you have to define your shapes in the shader. And like in your shader code. But yeah, we've done something very similar but with compute, but we're doing a sort of like a virtual machine type of way of doing it. Like this means you have to say if you want to like you have to do your UI in shader code, right? You're drawing it, whereas R1 can be controlled from the CPU. So if you want to put your rectangle at a certain place, you have to literally write rectangle, at some coordinate. And that's not very dynamic, right? It's compiled into the shader. Yeah, that's what we're kind of doing, but we do a compute shader over the whole screen, or we used to, but we're just removing that actually. But yeah, we go over every single draw command per pixel. But again, we used to do that. We're going to be removing that. Oh my days! You know what I just realized? We didn't update this to be taking it from the tiles, did we? The tile array. So it shouldn't have. Right, that's interesting. But yeah, it's SDF, so definitely another way to go. If you want to like draw shapes, like different shapes around the corners and everything like that, use SDFs. And you can use them with like, you can draw tons of different shapes with them. They're really flexible. Dropping all your videos on me again. How's it going? No worries. You're streaming some cool stuff, so gotta pass them on somewhere, because there's not many people who stream writing games and that in C or C++, doing some low level stuffs. Use vertex buffers for lots of triangles around the radical. Yeah, that's not great though. That's the way you can do it though. I've done that in the past. Hey Raymuch, how's it going? You could also like software render it on a CPU and upload it via texture. Bam. You can also. Oh, wait a minute. Microservices. You can send a request to a server. It can give you back the rendered image, and you download it, upload it to the GPU, and bam. Yeah, microservices. So how we're going to generate the random pixel color? Well, we can do that based on the tile list index multiplied by some big prime to make it make it completely different color. So have we got an FNV hash in here somewhere? I don't think I do. FNV I want to just grab the big prime, you know, find Optimus. There we go. They're both prime numbers, something like that. Big old prime. So, yeah, multiply by that prime, please. Wait, you multiply by the offset basis, isn't it? That'll be the prime. No, it's initialized, right? Yeah, multiply by the prime. Cool. Multiply some big old primes so they get spaced out. Then, right. Something about this. I wish I could pay you for favors of time, but stream schedules. Yeah. Yeah, it makes sense. That always happens though, you know. Like when people raise you and then you can't pay them back. But that's cool. That's the way things go. Yeah, things are good though. We've just got we've finished up on our renderer. So we've got like using sign distance fields, we're drawing like draw commands out of little a draw command contains a list of sign distance field operations. It's like a little virtual machine. So, you know, this one will say shape circle, shape box, and then that sort of like puts a bunch of distances on like some distance stack, and then you can say union, and it unions them all together, puts one distance back on the stack, and they've got like a gradient operation which runs and colors it in. So there's like a kind of really flexible 2D UI renderer that we've got, and we even got it so we can clip using that flexible like virtual machine type system. And when you sort of color it in, it's the alpha channel only, so you can alpha it. So it's super cool. We're just currently making it go fast because currently it's kind of slow. We're doing about full screen. We're doing about 13 draw commands, and it's about 0.0. Wait, it's 0.5 milliseconds, and that's very slow because it won't scale because every pixel is going over every single draw command. So we're trying to bin them per tile right now, so we can have a short list of them. So we're just getting the tile-based renderer in for it, and it's all in software using compute. Open a shell where you start OBS with a browser source that renders the box with the rendered radius. Start recording it, one keyframe, end recording, read the video file and blit it to frame buffer. Yes. I wonder how long that would take. But yeah, I'm not sure how much worse we can go with these ideas. Well, we can actually, there's many ways. So this gives us some big number, but we kind of need to be in the range between 0 and 1, I think. I forgot what they need to be in actually. We just want to got some functions. Right, do we just want to fract it? Yeah, but we can't because it's integers anyway. It's integers anyway, isn't it? So we could wrap it around about every 256. That's not a lot though, is it? So we can mod it around every 1024. Maybe 256 is enough. And then we divide it by... Or we could just divide it by that number and then fract it, right? So that just gets the... There you go. So yeah, it gets the fraction of that. Now, so that's the hue. What is the saturation going to be? So, you know, you know, every like 16-year-old would be like, oh, just put it at 1, all saturation. But, you know, I guess things get a bit ugly. So let's do like, I don't know, something like that. And also, how bright do we want it to be? Let's say 7.5, maybe 5, half brightness. I don't know. Cool. Now we've got it in RGB space. Turn it into sRGB, and then writes that out to the display. And let's see if we get anything showing up. And we can just start debugging it now. Huh. Yeah, quite a lot of stuff going on. Lots of fun. Lots of fun. Like the idea is just to make something that's like super powerful and flexible. So maybe we can build like an editor on top of it, and we can make these scalable custom logos and icons and things just in the game, and they could be animated, or they could be baked down. But I won't need to make that tooling right away. But it'll be something we can do later on. You know, when we get bored doing other stuff, we can just go and build that thing. So yeah, should be cool. Why didn't I like this thing? Oh. Too many brackets. Oh, sorry, brackets in the wrong place, rather. Right, so this needs, there's a 3 version. No W, but there's a 1 for the alpha, please. Oh. Yeah, I don't have shadowing support in my... let's call it CC. In my shader compiler, I don't have shadowing support, which I guess could be a feature. But yeah, so it just failed to compile. Right, so it shouldn't crash. So fingers crossed. Right, so we're getting a bunch of different multicolored things happening at the bottom here, which is really, really, really weird. Like I can zoom in on it. So it seems like we're right into the same place. Kind of. I don't know what's going on, right? So what we really want to tell is how many are we... Crap. What we really want to find out is like how much are we writing here. So you know how we can tell that? Very easily. Well, we've got printing. So we can just print it out into the terminal. So in the shader, we can just go BC, wait. SV dispatch index x equal 0. So the first one is going to do GPU printf, and we're going to print out how many tiles there are. And then we shouldn't get spammed by absolutely tons of these, just the first thread. It just happen every frame, those all. And let's find out. Right. Okay, maybe someone else was wrong there, but there's 65 of them. So there's only 65 tiles, apparently. That feels wrong to me. Only 65 of them apparently got a draw command in it when they're meant to be filling the whole screen. Printf, oh yeah. Yeah, it's definitely handy for moments like this, when all the data's on the GPU, you know? Definitely need it. Um, so if we're only hitting it 65 times or whatever, then surely this insert index should never go any more than 65, right? There you go. Look at that. Increments. So that is a weird. So you're doing 8 by 8. Should we check the dispatch size and all that? So we can basically start debugging this quite easily, I think. So we'll keep that insert index in there as well, because that'd be nice and easy to help us figure out what's going on. So we're going to put in some more information. So should we figure out like what? So dispatch X, dispatch Y. So what are we binning? What are we launching by? Am I not launching enough? So each thread is doing, so there's 8 by 8 tiles being operated on in here. 8 by 8 tiles. Any G tile size. That's wrong, isn't it? Crap. Yes, it's only doing 8 by 8. Okay. That's the problem. So the number of tiles that go across the screen. So what we really need is like so number of tiles. Yeah. BC tile dims. So that is displaced width divided by tile size. Right, so that's one issue. I don't know how many else we got. So we might get a whole screen just dancing with pixels in a second. Let's see. So this one would be the coordinate BC tile dims. So see how many of these guys we get. Oh, I did an S version. That's why. What? What did I do to my... Tiles count doesn't exist anymore. Oh, it's insert index on it. Right, let's run that. So we should be getting far more now. There we go. So we're getting like but let's at full screen set of tiles. Now, as you can tell, things are being offset, but it doesn't seem like it's offset enough, and that looks pretty sweet, doesn't it? Look at that. Doesn't that look good? But yeah, it's obviously not what we want. So we're getting a bunch of data races, basically, right? So I think the way the pixel coordinates being made is wrong somehow, but I don't. Oh, because we didn't times it by. So that's our tile coordinate, but we didn't times it by the size of the tile, did we? Right. So what we really need to do is multiply s u32 times 2 with gfx ui tile size. Right, and this thing here needs to be tile size by tile size. Because you're doing a whole tile within a thing. Which then means in the dispatch, when you do your divides... Oh, no, maybe not. Cool. Right, so now I've got a full screen of crazy pixels going on, which is good. But there's an issue with it still. It's running over every single draw command still, so we're not going to need any performance increase, obviously, from that. Oh, wait. Sorry. We're doing this debugging, aren't we? So we should be seeing... So if we pause it for a second, I guess you can't. That looks like tiles to me, doesn't it? So we've done that hue saturation thing, isn't it? Yeah. So these are 8x8 tiles. So you can measure it. Yeah. Yeah, 8x8. So we've got these. See, I was hoping it would be better. Like the hue would be better. But there's something. Should we try and get nicer colors? But it's kind of looking the same across the diagonal. I thought dividing it by 1024 would be enough. And he's in fracs, but maybe 256 is better. Maybe not. Should we do a higher number then? They kind of act weird diagonally for some reason. Any resources on an IR? All I can find is some PowerPoint slides. Can't find the actual talks. So searching for compiler stuff was quite hard when I did it. I just kept Googling, reading, thinking about it, and trying it over and over again. Like there was tons of little links that I just watched, and I was just saying PowerPoint stuff. Yeah, and I couldn't find out. Yeah, I couldn't find a good resource that just teaches you like it specifically. But yeah. Yeah, has anyone got any good resources for like a compiler IR that they can drop in the chat? Trying to make noise. No, I'm just debugging the tiles. So I think we've debugged the tiles just fine. Hey the Maple One, how you doing? So what we're doing is we're just coloring in each tile with a unique color. Or we tried to make it unique at least, but it kind of failed in some regard. Yeah, that's it basically. Yeah, some unique color because we're doing some tile-based binning. So I'm just trying to identify and make sure that the tiles that are rendering on screen is going to be, yeah. Um, yeah, just trying to make sure that the tiling system is actually working, basically. So, what else can we do? So I'm trying to make sure if we can like. So if we make the seed instead a pixel location, then it should be fixed, right? Because the problem is this is random, basically every frame. So it just looks like noise and it's crazy. So instead, if we take the actual pixel coordinate, or just take the tile coordinate, right? Take that itself, and then instead do a dot x or dot y times tile coord dot x, and that should give us a more fixed. There you go. So the problem is now is I don't know how well the hue saturation stuff is, right? Like, did I copy this correctly? I guess we can try this, right? Why don't we, let's put in 0 here and see what it does. So you get like a red color. Let's cycle this up 0, 1. What do we get? Goes more towards green, I guess. Yep. Blue. Yep. And it should make us all the way back around to red again. So I think that's working, right? Hue saturation, whatever. Then you go back to 1. So really, we don't have to fract it. I think it would probably do it anyway. But yeah, I was thinking then, right, it's probably good enough. That gives us like different colors. Although, when they get to, what's quite fun about this is you can see a pattern sort of emerging from it. Which is probably to do with when X and Y are sort of like, we're doing X times Y here. So we'll see patterns emerging. So maybe we can do like, I don't know if that's made it any better, to be honest. Oh well. Okay, we'll just leave it as that. That's a good little debugger, right? So that just shows you the tiles, basically. Group ID. The problem with group is it'll be different every pixel. Like, you don't know what one you'll get allocated. Is that right? We'll try it. I think it's tied to... Yeah. So it changes every frame. Like, you don't know what you'll get basically. Oh, right. So now we know our tiles are being allocated fine. Now we just have to swap over. So we'll disable this now. This is like visualize the tiles. Some of that, got a nice little debug thing in there. So here we go, here it is. So it's still slow, but you got yourself a tile binning thing. Why is it still this slow? Well, because what we didn't do is use the new array. So you got yourself a tile list. This got us our tile. But there's another array. Tile draw commands. Now this bugger has all of our lovelies in it. So we need to get the tile start index. Something like that. Which means we work out tile index. Something like that. Which would be tile coordinate dot y, tile coordinate, times the tile size plus dot x, so it just flattens it. Get us the start index into the draw commands, right? Now here's the interesting thing, is we'll have a maximum iteration size of the capacity, right? Maximum iteration size of the capacity. But we'll stop if we read a draw command which is equal to 0. Is that a good idea, or should we store a count in there? Because then you've got 0 the memory. Oh, we could do a for loop which zeroes the memory at the end of the shader. But then you get this divergence everywhere. We could zero the buffer with a shader. Or we could store a count in there. So what we could do is store a count. So when you have a draw commands capacity, what you really have is, this is when we're binning it. We're going to stop you at that much. And we'll make sure you put it one ahead, right? And then at the end, we'll simply store the count at the start, right? Yeah, I don't know how good of an idea that is, but that's the idea we're going with now. So we can fish the count out. So you have a sort of like a draw commands count. Now you don't need a draw commands count to be passed in anymore into the shader, because you've right. So this one will be tile draw commands count. So this would be in that sort of like BC tile draw commands. Then use that tile draw command start index. That's where the count is, right? And then we'll min it. Do a little cheap min with the capacity just for safety. How's the game event engine going? It's going pretty good. We've got so run on Windows and Linux. We've got gamepad support. We can open up a window. We've got gamepad, keyboard, mouse support across Windows and Linux. We're just finishing up on a 2D renderer which uses nothing but SDFs. We're just trying to optimize the crap out of it right now. And then we're going to be doing some UI. We're making a quick UI system. So how long will we brand it as Hero Dev Engine? Never. Never. Yeah, it's pretty good. Made some really good progress, actually. You know, we'll get to making a game at some point, but just doing some graphics basically. Yeah, we're not going to like. So, if my opinion, so I'm currently going towards liking this, where you build everything from scratch, and you know, because I can, if I want to reuse it, just copy paste the code over, right? I don't have to maintain this code base, because part of the reason why I delete a load of test code is because I don't like maintaining it. So like when you have like a big engine, you basically have to maintain the big engine. And I'll find myself throwing it away anyway. So I think being able to, you know, as long as you separate stuff into folders, right? You know, get, you know, we've got like a GPU abstraction. We've got a core set of core stuff for like, you know, memory allocation, all that stuff, OS layer, UI thing. You know, we can take these bits out, put in a new project, and off we go. Just do some refactoring, right? So, like, it's, you know, it's not like you're building it all from scratch every time. But yeah, you might want to throw it away, and that's fine. What kind of game are you building on it? Nothing yet. I don't know the game yet. I want to do some graphics R&D, and then I want to sort of have a you know, we can actually play around with visual things, and then I can sort of get an idea of what I want the game to be. That's part of the input as well as many other things, and I can laser focus on doing the game sort of design stuff. Oh, I hear you, man. I was just picking on you coming in. No worries. That's fine. This is fun stuff, figuring out how to do the hard things. Yeah, it's been good, and plus it's great when you stream, like, because you know there's like people who do like YouTube only. They go, oh, streaming's like annoying. Streaming's a waste of time. But obviously it does have its pros and cons. But the pros are, right, like if you don't know something, someone else in the chat does, they can help you out. And there's been some stuff where, like, sure, you do program slower because you're talking to people, and you know, maybe someone says something that sort of changes your mood or whatever. But people also come in and know stuff that you don't, and it just makes the code better, you know? And you get to learn stuff as well. So, highly recommend streaming if people don't stream already. And plus, if you do see programming and don't stream, you need to start streaming. Should make a game like Shenzhen IO or TOS 100. I don't know. I'm not so much into thinking games myself. I'd very much try and like make a game that I would like to play. And if I would love to, and I've actually started playing it, that'd be amazing. But because I spend too much time thinking during the day, and I don't like thinking when I play games. So I want to try and have a game where, you know, I guess there can be some kind of thinking, but I don't want to have like, you know, 4D chess level of thinking. Base to stream. No time now. I've got a baby. I got you. But yeah, I agree. You code slow, but you have great discussions how things work. Yeah, that's it. And also you get to like draw things, and you explain the problem more to people and force to draw things and be like, oh, so this works. Right, so that will reduce the number of draw commands down to the binned amount in the thing, right? Oh, and we could have some. We can visualize the number of draws per tile based on, and do that as a color. How amazing! Like we can make it get more red from like yeah, easy. We'll make it get more purple for those colorblind people. Yeah, then we'll go into command, tile draw commands, tile draw commands start index plus, oh yeah, there you go, bam. Rightio people, we got ourselves a fast renderer hopefully. Please don't crash, please. Right, now it doesn't render on the screen, but it's fast. Okay. So we can compare it in a bit. So I'm not seeing anything in there. Oh, is it because we didn't start from 1? Fish out that, add 1. Oh, that could have crashed the GPU so hard. Right, there's something fishy going on. Right, so when you're binning it, you come in to here, add 1. You got the start index, add 1. I don't know. Yeah, when it gets to 1 less, it's false. I'll stop. Good. Should stop, and then you're saying this plus that. No, not plus that, plus nothing. Good. That'll be it. Oh no, maybe not. So when this reads it, you're the tile coordinate. So that's, you're packing in the tile itself. Yeah, the tile XY. So you pack in the tile XY. I know, right? Long variable names for the win. I do shorten them sometimes, but yeah, they stay long mostly. Tile X, sorry, tile Y times. So that gets you a flat index out, right? We are syncing, so that's not the problem. Oh my days, command index less than this. Whoops. My mistake. Right, I see pixels. Okay. So we should be landing in here, but we're not. Oh, this is really, really sketchy. So should we do another debug renderer? And this debugger is measure the number of draws. Per tile, right? So you mean like so we'll mean like purple equal none, and then like red equal something like that. So what we'll do is obviously move all this silly stuff up here, and then we'll grab this game. So red will always be on, and then we'll just go to blue, right? So you just do something like so red will always be on, green be off, red would be equal to tile commands, tile draw commands count divided by this guy here. Then 1 for the alpha. Alright, so this will just paint the screen in those colors, which would be super lovely. And hopefully help us debug what's going on. Alright, so we're not getting the... which is weird, right? We're getting purple here, we're getting black. So... did we go out of bounds? Did we... what did I change? We're still dispatching the same amount. Should I print out this? Insert index, wherever that is. GPU hprintf. Because we should be getting tons of these guys going, right? Did we compile that? Hey there, Ansel. How you doing? Why aren't I seeing any printing? Did we bugger something up now that we've added this in? We should be seeing stuff printing. No, what have I done? Why can't I see any prints? What did we add here anyway? That was a bugger. I don't know what could have changed. Right, let's just put another print thing out. Let's just print this out here instead. Let's do tile draw command. See if this prints out. We're getting a bunch of zeros. What? Why are we getting a bunch of zeros now? What did we even change? Did I delete draw commands count? And it zeroed memory. I deleted draw commands count twice. I deleted it in the tile binning, so it basically didn't iterate over anything. Right, so that's maybe a bit problematic then as well. Is like, what happens if you don't draw anything? What is going to happen? We should probably zero something out. Oh no, we zeroed. Yeah, that's fine. What we're doing today, we're doing some tile-based rendering. Right, so we've got fully red. What does red mean? No, red means good in this case, damn it. We meant to do the other way around. And also this should have been like casting into float rate. We're binning them per tile, Ransel. Our draw commands per tile, so we are not iterating over every single draw command per pixel anymore. So we've got a quick phase which goes over every draw command and then bins it into a screen tile. So we split the screen into a grid of tiles basically, and we have an array of draw commands that we throw them in. And then we go over per tile, and each one of these is running 8x8 tiles or whatever. So we should be running less draw commands per pixel now, so it should be going super fast. That's the idea. Though we should be doing one take to get that to be a nice color, yeah. So we should be seeing like, we're seeing purple. None. I don't know how good this is, really. But anyway, we'll turn it off. We'll see as we do the other testing. Right, now it's got blue screen. But we're doing a whole bunch of printing here, so there are things being inserted. The problem is something is still wrong. So we're getting the blue background. So I thought I'd be fishing out my tile. Suppose I'm not fishing out the right tile. Sorry, draw command out, that's what I meant. Fishing out the right draw command out, so why is... Right, let's reread over this. So you finish and you insert this thing in. We know things getting inserted. So we insert shift left 16, ORed with that. That's not going to go over 65,000, so it'll be fine, right? Chuck that in here, it's a 32-bit integer. Chuck it in an insert index, it's fine. Tile draw commands. Insert at the front. So tile index times by number of draw commands. Insert that at the front. This is the count that we've accumulated, basically, of draw commands that we've inserted into the tiles draw commands. Right. What's going on? So we dispatch over dispatch group X. So we only increase the X by the number of tiles. We get our list index. If we go outside of that, right, we fetch our tile. If we go outside that, we return. We fetch our tile from the list. Crap. It's got to be list plus 1, hasn't it? Because list 0... Wait, is that right? So list... Yeah, list 0 has the atomic counter in it, doesn't it? So what you really want to do is say UI tiles start index plus that. So there's that problem solved. So then you pull out your tile coordinate. Your X is in the first 16 bits. You know, really we should mask this, right? And then your Y is in the upper bits, 16 bits. There's your coordinate. Now, your coordinate is a tile, right? So to get a pixel coordinate, it's tile coordinate times tile size. So that will get us the start pixel, then we add the local index, which gets you this guy. So we've got the coordinate here. If we're outside the dimensions of the screen, return, bam. I got a coordinate there. So we've done the visualizer fine, we know that works. But this other visualizer we've got, yeah, so we can visualize the tiles where we see them in different colors, we know that works. Then, see, I guess I want to move some of this stuff below here. Right. So this gets the tile index, which is tile coordinate.y times. Now that's wrong. That's the problem. The problem is that should be the number of dimensions. I made that same mistake earlier. Damn it. Right. Yeah, we're getting close to the number of... Yeah, it's the number of screen tiles that go on a screen. Okay. So that gives us the number of tiles on the screen. Which means we need to use that in the shader. So that will go here. Dot X. Hey, Cospel. Well, I don't really have much of a game yet, but we're doing all the sort of build up to it, like all the engine stuff. But we're currently just trying to get the UI. So we haven't got anything visual in terms of game wise, but we've got cross-platform Linux, Windows, got gamepad support, keyboard support, mouse support. We've got a GPU abstraction. We've got a 2D renderer for UI, which uses sign distance fields and does all these lovely unique cutouts and things like this. So where's my thing? Yeah, so ignore all these lines here because we've got these like. Oh, okay. I got a Twitter. This will be better. So essentially, we have, yeah. So we have ways of like doing all this sign distance field based clipping and shapes and all sorts of lovely stuff. So we're gonna have some super flexible UI rendering, basically. So we're trying to optimize it right now because we run a compute shader per pixel compute shader that simply runs. It used to run over all of the draw commands. But now we've binned it per tile and we're just running over it per the ones in the tile basically. So we're just optimizing it, making it go fast. Tiledims.x. Yes. So that seems more sensible. So let's just read it just in case, because it could crash the GPU if we're wrong. So the start index is tile index times the number. Yep. The count is extracted from the first word. We're going to min it with the capacity as well, just so we don't go out of bounds. Then we increment the start index by 1 because that's where the count is anyway. And then we go over all of them, increase that, good. Get the draw command, get it from there, the start plus that, and voila, rightio. So let's try that out. Does it work, please? Oh, GPU crash. Right. Sweet, that didn't... Right, so we're back now. Very good. Yeah, the min didn't, so it's some other problem then. I don't know what it would be. So I have to analyze the code even more. Thought I analyzed it, but no. That's a shame. Are we putting the word the right... Pull out the draw command, put in the draw command. Kabam. Should be fine. Right, we're going to start outwards and go back inwards. Okay, so we're definitely setting all of these guys up right, aren't we? Like we've got, yeah. We also have the read only things there, so it should be synchronization code. you know, we also can verify. So what did we change, right? We've noticed that this tile index, this is probably the issue. What do we times it by up here? Did I times it by someone else? Oh no, that was wrong. Wait a minute. What is this? Huh? So this goes over per tile. How does that get you the tile index? Um, oh, yeah, so that does get you the tile index. Right, so that was right, maybe. Do I need tile dims in here then? So that's your tile coordinate. No, that doesn't get you the tile. Right, I think the tile index is wrong up there. So we want to flatten this one out. So, yeah, it was looking in two different arrays. There's two different parts of the array. So that would be BC tile dims. Yep. So basically, right, so let's just double check that quickly. So this one we're doing the binning, it gets you the tile index. That one was a very small number, was obviously overlapping a lot of stuff then. But yeah, so if this dispatch index, you're going over every single tile on the screen, then you've got a 2D coordinate, you want to flatten that out, you need to take the width of the screen in tiles, and that was the problem. Right, that seems to make sense, because it was pulling out from the wrong buffer basically. So, let's try this one. Right, fingers crossed don't crash again, because that would be annoying. But anyway, please be fine. Oh yeah, there we go guys. Right, so that is using the new tile renderer. It's actually only a little bit faster. So the performance we was getting before is 0.56 ms, and now we're getting 0.42 ms. So every single pixel is only running over two draw commands now. The background, which is blue, followed by the background, which is blue, and then followed by which one is here, basically, right? That's pretty neat. So it is faster, but the benefit of this thing is it's going to scale. Yeah, it's going to scale basically. But yeah, we definitely want to like spend a lot of time like seeing how good it actually is though. So let's increase this, or let's enable this, and let's get visualization. Yes, so I don't know if you guys can see, but there's two different shades of pink. Like if I were to do times this by 2 or by 4. Right. Can you see here how the tile, like, so we're going pink to red. Maybe I should have gone green. Done green. Red to green, maybe. I don't know. Oh no, I should have taken away the... Let's do red to blue. Yep. So here's the offset. That'll be better, because then it has less of a color in it. Some opposites, I think. Maybe red and blue. Hey there, Dylan. Um, yeah. Hey there, welcome. How you doing? I was going to try and pronounce your name, but I am super tired. How's things going? Welcome to the stream. So this would just be the sort of like offset, I guess, or the I don't know how much, like how many, or like ratio we'll call it. So with this sort of ratio, I guess you want to sort of like red is bad. So blue is cold, right? Okay. So it'll just get more and more hot basically. So if I times that by like 4, you'll be able to see this more distinctly, right? Oh, come on. Sorry. Yeah. So as you can tell, right, the background's got 1, and then there's these ones here. So it is working, right? So that's a nice little visualizer there. I like that one. You know, 16 shades. You can still work it out. So that's cool. So the next thing we could try and see is like how many VGPRs are we using in these things. So let's run this. Get the text document open. Right, so we ended up doing 42 VGPRs. Oh yeah, because we've got that dumb thing in there still. Amazing. Even more optimization. Here we come. Get ready for this. This thing is going to blast. I hope. Right, so we're going 0.4 ms. So hopefully that'll be less. It's just under. Yeah, so it's from 0.38 to 0.4, and it's damn it. Yeah, so that did get better, I think. Should we undo it and just see? So this is a little bounds check that we had per draw command. So if your pixel was outside of the draw command, it would continue to the next one. But the problem is you're doing 8 by 8 pixels, and some pixels might be outside and others won't, and you basically just create some divergence, and it's not very good. So that was going from 0.4 to 0.43, right? So we did get a nice little boost on there. And we would have reduced the number of VGPRs as well. Reduce the VGPRs to, 38 there. So, 38 from 42. So we've got 40 allocated. Ideally, it would be nice to get down to 32 VGPRs for older hardware, but that's fine. Right, so this means then the tile renderer is working. What is left is we want to right. So if we're lucky, when we scale this up, this number shouldn't change too much, this 0.4 ms, but the number in the binning will change. And we'll just see how that is. So, pretty decent. Yeah, so in the next stream, what I want to do is fill this screen up with tons of stuff and just really test it out, and we'll see what we can optimize, basically. Maybe we can optimize this tile binning shader some more. Maybe there's a little trick that we can do to optimize this shader. I think there's one that we can do still, where it will increase the cache. We want to make sure when we're reading from buffers or textures that we get sort of more of a better cached read, basically. So I think there's little tricks we can do. But yeah, that's pretty decent. So I think we'll spend one more stream on optimization, and then we'll call the UI rendering. We'll finish it basically. Yeah. Right, so our next Beyond on Thursday, 6:30 p.m. GMT +1. So yeah, you can follow me on Twitter. There's links and stuff. Which C standard am I using? C11. Over Twitter, I have a... yeah, if you guys want to see the code for this, it is going to be uploaded to a GitLab. If you support via Twitch or Ko-Fi, there's links on the Discord there. You'll be able to follow it, and yeah, you'll be able to download and play around with the code on Linux and Windows. But yeah, let's find someone to raid. C++. There we go with right. Hope you have a good tomorrow and Thursday. Everyone, I'll see you all on Thursday, hopefully. And yeah, thanks for coming. It was a great stream. We made some good progress. We're seeing some improvements already, and hopefully when we scale it up, we see that it doesn't get impacted as much. So that'd be cool. Right. Have a good one, guys. See you later. Bye.